All right, everybody, we are ready to get started here. How's everyone doing today? Good, good. Welcome to the Morrison Planetarium. My name is Mary. I'm going to be your tour guide for our tour of the universe today. And this show is one of my favorite shows that we do because it's a little bit different than lot of the shows that we have throughout the day. Most of the shows that we have throughout the day are pre-recorded movies, basically, with a short section where a presenter can update you on a particular topic. This show is a completely live show, so I'm going to be our pilot as we fly around the universe today. We're going to start out at Earth. We're going to zoom out as far as we can out into space, and then we'll come back safely home at the end of our journey. But in order for us to go on our tour of the universe, I do have to head all the way up the stairs to our pilot's booth, which is at the very top of the room up there. And on my way up, I have a few quick planetarium rules to go over. First of all, please no eating or drinking while you're in the planetarium today to make sure to keep our theater nice and clean. If you have a cell phone, a camera, a tablet, anything at all that could give off light or sound, both of those can be very distracting in here, so we want to make sure that those are all put away during the whole show. For your safety in this dark theater, we highly recommend staying seated throughout the entire show, but if you find that you need to leave early for whatever reason, the exits are at the top of the stairs on either side. And last but not least, this can create a very immersive experience. So if at any point throughout the show you feel any dizziness, any motion sensitivity, just go ahead and close your eyes for a few seconds. And that will help your brain remember that you're just sitting in a chair in a planetarium, not actually flying around in space. So without further ado, go ahead and sit back, relax. Give me a minute here to move into our pilot's booth and we will get started. All right. So, we are starting our tour of the universe today relatively close to home, just a few hundred miles above the Earth's surface at the International Space Station. And I always like to start out our tours at the International Space Station because it gives us a little bit of perspective on where we're going to go today and the incredible distances that we're going to cover. Because the International Space Station, this is as far as humans travel out into space right now. You can fit about 6 astronauts or so on the International Space Station at any one time, and people have been living up there for a little over 20 years now. Though not the same people, they do swap out every few months or so usually. The longest that any one particular person has lived there was about a year. But this is as far as we go right now in terms of humans going out into space. But today we're going to see how far we've gone in the past, how far any of our spacecraft have gone, how far anything we've sent out into space has gone, and we are going to go much, much farther than all of that. And right now we're seeing where the International Space Station is above our planet. So you can see it's very dark behind it right there because it's on the nighttime side of the Earth right now. Let's zoom out so we can see the path of the International Space Station as it goes around the Earth. And this is its real time location. And that's because everything we're going to see today is based on actual data and actual images and things of the places that we're going to visit because I'm using what's called OpenSpace. It's a free open source software with using all real data. So this is where the International Space Station is right now. And if you're ever curious, you can look up where the International Space Station is. If you just Google or search for where the International Space Station is, it can tell you when it's going to pass overhead. And it's pretty easy to spot. It looks like a pretty bright star moving pretty quickly across the sky. And as we zoom away, you can see their path in yellow there. They're going very quickly around us. The ISS takes only about 90 minutes to orbit us once. So they're going around really, really quickly. And if I go over to the daytime side of Earth, we can also see some real time weather patterns and things like that from early this morning. that were updated in the OpenSpace software, so we can see where there were some storms and things like that on the Earth. But I'm not going to stay here at Earth for very long. In any place that we go in our tour today, we're not going to stick around for very long because we have a lot of ground to cover. So we're going to be going pretty quickly from one place to the next. And our next stop on our journey away from our planet today is going to be our closest neighbor in space, our closest natural neighbor, the moon. So I'm going to focus on the moon here in just a moment. There we go. And I say our closest natural neighbor because we do have a lot of human-made neighbors, a lot of satellites and things going around our planet, but the moon is our closest natural satellite going around us. And looks like we're coming up on the dark side of the moon. Despite what some songs may make you think or something, there is no permanent dark side of the moon. That changes as the moon goes around us, which side is dark and which side is light. However, there is a permanent far side of the moon. There's this one side of the moon that always faces away from us. So in a moment, we'll see that as we rotate around. And the moon, this is as far as humans have traveled out into space so far. The Apollo astronauts came out here in the 1960s and 70s. And it took them at least a couple of days to get to the moon because while it is our closest neighbor, it's still about 250,000 miles away from us. So pretty far away. And here at the moon is where I like to introduce an idea that I'm going to be using throughout the rest of the show because we're going to be looking at some really incredible distances. So already we're up to over about 250,000 miles away to just get to the moon. And we're going to see distances of millions or billions or sometimes even trillions of miles and kilometers as we get farther away. So as we get up to those incredible distances, it starts to pretty quickly not make a whole lot of sense if I use miles and kilometers to tell you how far we've gone. So instead, I'm going to use the speed of light. Now imagine, if you will, traveling the fastest speed we know of in the entire universe, the speed of light. If we were traveling at the speed of light, it would take us about 1.5 seconds to get to the moon from Earth. So we can say that the moon is a distance of 1.5 light seconds away from us, about how long it would take for light to get here. So about how long it took for us to fly over here in open space. And we can see here the lovely far side of the moon. This is the side that we don't get to see from here on Earth. A lot fewer dark areas on the far side of the moon. And off in the distance, we can see the Earth over to the right a little bit there. But let's zoom back out because, again, we got a long way to cover. So we got to make sure we're going along at a pretty quick pace here. And I'm going to bring up some more lines so we can keep track of the things that are in our solar system as we zoom away. So these blue lines are showing the orbit of the moon and then also the orbits of the planets in our solar system. And I'm going to focus for a minute on the very center of our solar system. We're going to take a look at the closest star to us, very center of our solar system, the sun. Now, if we were traveling at the speed of light, it would take us a few minutes to get to the sun from Earth. So the sun is about 8.5 light minutes away from us. There's a couple of ways I like to think about that. One way is that if the sun just disappeared, we wouldn't know about it for 8.5 minutes. Thankfully, there's no reason why the sun would just disappear, though, so you don't need to worry about that too much. Another way I like to think about it is that if you walk outside and you look at the sun, first of all, please don't do that. Never, ever look at the sun. It's very bad for your eyes. But if you were to look at the sun, that's how the sun looked 8.5 minutes ago, not how it looks right now. So within these few light minutes of distance, we're seeing the orbits of the smaller rocky planets in our solar system, Mercury, Venus, Earth, and Mars as we go farther away from the sun. And then farther out still, we're seeing the orbits of Jupiter, Saturn, Uranus, and Neptune. And you can see that it looks like there's a pretty sizable empty gap here in between Mars and Jupiter, but that's not totally empty space. That's where we find a lot of the smaller rocky objects in our solar system, where we find the asteroid belt. I'll show you where the asteroids are. Now, most, though not all, of the asteroids orbit in between Mars and Jupiter here in the asteroid belt. And then if we keep going out farther past Jupiter, Saturn, Uranus, and Neptune, there's another area in our, another belt in our solar system that's sometimes, I think, a little less well known. So we got the asteroid belt in between Mars and Jupiter. Way out here, we have what are called the trans-Neptunian objects, objects that orbit beyond Neptune, including the Kuiper belt. So you can see this kind of larger belt farther out in the solar system. This is where we find a lot of icy objects and a few objects that are a little bit bigger in size, a few dwarf planets. And perhaps most famously, this is the home of our favorite dwarf planet, Pluto. So I'll show you the orbit of Pluto way out here. Now, if we were traveling at the speed of light, we've already gone a pretty big distance here. So we've already jumped up from 1.5 seconds to get to the moon, then 8.5 minutes to get to the sun. Way out here by Pluto, it would take us about 9 or so hours if we wanted to travel from one side of Pluto's orbit to the other. So we're up to a few light hours of distance, really far out in our solar system here. And this is a good point to check in with any human things that we have sent out into space. So we saw so far how far humans have traveled out into space to our moon, our closest neighbor. Out here, we can see how far our spacecraft have traveled. So those will come up in just a second. So these are showing the farthest and some of the fastest spacecraft that we have sent out so far out into space. So these are showing us where Voyager 1 and 2, Pioneer 10 and 11, and New Horizons, where they've gone out into space so far. So New Horizons flew by Pluto a few years ago. But even so, even though these are our farthest spacecraft, some of these were traveling since the 1970s, so a pretty long time now. None of our spacecraft have gone as far as light could travel in a single day yet. So we're still out at light hours at this point. We haven't quite gotten out to light days yet. But around here is kind of a tricky gray area when it comes to things out in space of, are we still in our solar system or have we gone outside of our solar system? If you've heard of the Voyager spacecraft, you may have heard about them leaving the solar system. Maybe you heard about them leaving the solar system half a dozen times, because where exactly we leave our solar system is a bit of a tricky question. It's not a hard defined line of where our solar system begins and where our solar system ends. But around here, you'll see the sun start to shift here. My model of the sun that we have in OpenSpace is looking a little bit different, because before I was dimming down the sun so that you could see the other things in our solar system more easily. But now we're looking at the sun with its true brightness. If we were really this far away out in space, this is how bright the sun would be. And as we move away from the sun, in a moment, you'll start to see that we're flying past other stars in our galaxy. And once we start to fly past other stars, there's no question whatsoever anymore. We are definitely outside of our solar system, and we're in interstellar space, the space in between stars. Now out here, we've got another big jump in distance. So we were looking at some few light hours of distance to go across Pluto's orbit or to get to our farthest spacecraft. Now, if we wanted to travel to the closest star to us out here in space, it would take us about 4 years if we were traveling at the speed of light. So the closest star is about 4 light years away from us. So there's a reason we call it space. There's a whole lot of space in between things out here when we get far away. And something that's really exciting and an interesting part of astronomy and research out there is the fact that these stars are not all alone floating out here in space. Since the mid 1990s, we've discovered that many of these stars have planets around them, what we call exoplanets, planets outside of our solar system. So I'm going to bring up some blue markers here that will show us where all the exoplanets are out there in the universe that we've discovered so far anyway. So far, we're up to over 5,000 exoplanets that have been confirmed, and finding more all the time. And then we have a dedicated spacecraft out there called TESS, which is scanning the sky, looking for exoplanets. The new telescope JWST is also going to look for some exoplanets for us and teach us more about them. And around here, as we start to fly past many of these exoplanets that we found so far, this is the last time that we can check in with anything that we have sent out into space. Now, we've already seen how far our spacecraft have gone, so anything from here on out is not because we've sent something to these locations. We have not sent spacecraft or anything out here to take pictures. Instead, We're seeing what we're looking at because the light of these objects has traveled to us, and we can observe them with our telescopes. But we have sent something out this far into space as well, and I can show you where that is with this blue sphere here. This is what we call the radiosphere. So this is showing us how far anything we've sent out has gone, any of our radio signals that are going away from our planet. So we have been sending radio signals out into space for quite a long time now, since the 1930s. So about 90 years or so that we've been sending radio signals that are strong enough to escape our planet and go out into space. And as long as you don't run into anything out in space, you're just going to keep on going the exact same speed that you went. So those radio signals are traveling at the speed of light. And since they've been traveling for about 90 years, the farthest they could have gone is about 90 light years away from us in any direction. So that's how big this sphere is 90 light years in any direction away from our planet. And if you look carefully, you can see there are several exoplanets inside of the radiosphere. So who knows? Maybe there are some aliens listening to our radio shows right now. That'd be pretty cool. Unfortunately, we haven't found any aliens yet, but there are scientists that are searching for them, trying to see if perhaps some of these exoplanets could have life on them. No luck so far, but hopefully in the future we'll be able to find some. But we're going to keep on going, and I'll keep on our radiosphere as we zoom away from these exoplanets and from the Earth even farther. I like to keep an eye on the radiosphere, see how long we can spot it as we zoom away. And in a moment, we're going to see a shift in our model of our galaxy here. So in the background, we were seeing the kind of milky haze that you might see if you were to go out somewhere really dark and gaze up at the Milky Way. But now we're going to see a model of what we think our galaxy would look like if we could step outside of it. So we haven't stepped outside of our galaxy. We haven't sent anything out this far to take a picture of our galaxy. But we can get a pretty good idea of what our galaxy looks like from the inside of it. We've mapped it out pretty well. And based on what we've seen, this is what we think our galaxy would look like if we could go out this far. And can you still see the radiosphere? Yep, over to the left there, that little tiny dot. That is how far anything we've sent out into space has gone, just that little tiny dot. Because now we're looking at distances of thousands of light years. If we were to travel across the Milky Way galaxy, past these billions of stars, we think at least 100 billion stars, it would take us about 100,000 years, even if we were traveling at the speed of light, the fastest speed we know of. So our galaxy with its billion stars is very, very large. It would take a very long time to travel across it. But even so, even with how big our galaxy is and with the billions of stars it has, we think probably billions of exoplanets too, it's still just one galaxy out there in the universe. As we look around, we're seeing lots of other dots that have shown up here, and every single one of these dots is another galaxy. And every single one of those galaxies has its own billions or sometimes even trillions of stars. And if you're wondering about the colors of these dots, these are not the actual colors of the galaxies, unfortunately. I think that would be fun if it looked like cosmic Skittles out there in the universe. But no, these are colors because we've color-coded them based on different surveys and things like that. So which group or what telescope was used to find these galaxies, or which group of people search for these galaxies. And this is a real map. This is an actual map of where these galaxies are relative to us. But because it is a real map, that means that in a moment here, we're going to see something that looks a little bit strange. The shape that these galaxies seem to form as a group looks kind of odd. And the shape we'll see, it's going to look sort of like an hourglass or a butterfly or a bow tie, something like that. Now, I'm sad to say that the universe is not shaped like a butterfly, though I do think that would be fun too. Here, let me get a good angle so we can make sure we can see it. There we go. The universe is not shaped like a butterfly, though I do think that would be fun. The shape we're seeing is because we're looking at all of this from our perspective here on Earth. And we're seeing these pretty sizable gaps to the top left and bottom right here. And that's because of our galaxy. If you could see the Milky Way galaxy and the disk of our galaxy, it would line up really nicely with where those gaps are. Because when we try to look over in those directions, the gas and dust and stars that are in our galaxy are blocking our view, making it so we can't see over in those directions as well. So there are even more galaxies than this, but this is just what we've been able to map out well and what we've been able to see so far. And when we get this far out in the universe, something really cool too is that we are, in a way, kind of time traveling because all of this light takes so long to get here that by the time it travels all this distance and gets into our telescopes, we're seeing these objects as they were in the past, not how they look right now. So if you think about the beginning of the show when I talked about the sun and how where the sun looks like, that's what it looks like 8.5 minutes ago, not what the sun looks like right now if you were to look at the sun, which again, please don't look at the sun. Well, now we're looking at what our universe was like billions of years ago. These galaxies are billions of light years away. And beyond these galaxies, there's also some dots that will show up in orange in just a minute that are some of the farthest objects we know of, the bright cores of some of the very first galaxies, what we call quasars. But since this tour is taking us past where we can see all these galaxies and past the actual map of where these galaxies are, that means there's really only so far that we can go. There's only so far that we can see in our universe, and so far back in time that we can see too as we kind of time travel and look at these things very, very far away. And that edge of everything we can see, the edge of our known universe, is going to pop up all over the screen in just a minute here, what we call the cosmic microwave background. Now, if you walk outside tonight and you look up at the sky, you're not going to see this everywhere you look in the sky. Thank goodness. That would scare me if I looked up and saw all orange all over the place. But if you walked outside tonight and you looked up at the sky and you could see in microwave light, a lower energy form of light that our eyes can't see, but our telescopes can detect, you would see this every single place that you look. And actually, the first people to detect this were kind of confused because they pointed their radio telescope up to the sky and said, "Why am I getting some strange interference everywhere I look? What's going on?" But after a while of studying this, they realized it wasn't interference, it was actually something out in space they were seeing. And it was a really big help for the Big Bang theory at the time. Because at that time, people had the idea that if there was a Big Bang, then you would see some sort of like afterglow of the Big Bang somewhere out in space. And this was that afterglow. So this is what they predicted that we should be able to see before we were able to see it. And this is the moment when things cooled down and expanded enough after the Big Bang, when light was first able to go out and expand out in all directions. So before this, light was in a tiny area, it couldn't really go anywhere. But this is the moment that it was able to expand out and go out in all different directions. And so an easy way to think about this is the baby picture of our universe. This is the earliest light that we can see and as far back in time as we can see as we gaze at things out there in the universe. But since this is the edge of everything we can see in the universe and as far out as we can go, that means we can't go any farther. So to wrap up our tour, we are going to head on back home. I'm not going to leave you stranded out here in space. Now, keep in mind, if we were really this far away out in space and if we were really traveling at the speed of light, this journey home would take us about 13 billion years. But thankfully, we're in the planetarium. Should only take us a couple of minutes or so. Here we go. And as we fly back home, one more thing I do like to leave folks with is that all of this that we've been looking at, stars, galaxies, planets, exoplanets, gas, dust, cosmic microwave background, that's not even everything that's in our universe. There's some really mysterious things out there, things like dark energy and dark matter. Dark energy is some mysterious force that is causing space itself to accelerate as it expands. Dark matter is some mysterious substance that doesn't seem to interact with light at all, but we see evidence of it, a lot of it at the edge of galaxies especially. And we call these things dark energy and dark matter because we're not entirely sure what they are. But we do know that they make up about 96% of our universe. So all of this that we've seen so far is only a tiny portion of everything we know to be out there in the universe. And that may make everyone feel kind of small, that we're this one tiny dot in this gigantic universe. But while I agree, sometimes that makes me a little uncomfortable too. Another way I like to think of it is that, well, yes, we are this one tiny dot, but look at all of this that we have found so far, almost entirely by just looking through telescopes. And there is a whole lot more to discover and a whole lot more to learn about. And that is pretty exciting, if you ask me. But even so, I do feel a little bit of relief every time we get back to our galaxy and start to re enter our comfy human realm of the universe as we re enter the radiosphere. We've got about 90 light years left to go to get home. And we're going to head back to that closest star to us, the sun, which we'll see in just a minute as we fly through interstellar space. And we're going to head back to the third planet from the sun, where we've observed all this from, where we sent out our spacecraft and our telescopes out into space. Those farthest spacecraft that we know of, about a light day or so away. And back to the third planet from the sun, the only place in all of this where we have found life at all so far, which is also pretty incredible to think about, if you ask me. And we are back home. Hooray! So with that, I want to thank you all for joining me today for our tour of the universe. I hope you enjoyed flying around in space with me, and I hope you will all enjoy the rest of your day. Thank you all so much for coming.